Today we're going to analyze a situation where a projectile is launched at an angle. So let's take a look at this situation, and there you go, you see it in action. The question is, well, let's analyze the situation. A football is kicked with an initial velocity of 20 meters per second at an angle of 30 degrees from the ground. So if I have ground level here, that'd be this horizontal, and it's kicked at an angle of 30 degrees from the ground. And so we have several questions here. The first one is how high it will reach. But before we even start with this question, before we start with any of this, we should think to ourselves, well, wait a second. This is my initial velocity. Can I use this in calculations? Can I use that value of 20 in calculations? And the answer is no. You should be using your horizontal and vertical components for your calculations. So let's say, for example, like this, we have VI of 20, an angle of 30. Well, you want to split this up into x and y components. How do we do it? AX equals a cosine theta, and AY equals a sine theta. So let's go ahead and substitute, and we can split this up into x and y components. You say, okay, well, AY is therefore 20 times the sine of 30 degrees, and you make sure you're in degrees. And so AY is 10 meters per second. AX is going to be 20 times, and this is going to be actually the VIY. Sorry, the VIY is 10 meters per second because it's the y component of the initial velocity. 20 times the cosine of 30 degrees, and we get an initial velocity on the x-axis of 17.3 meters per second. So we have our x and y components here. It's important to split things into x and y components. That's always your first step. So if we're talking, how do we analyze the situation? Step one, you're always going to split it up into x and y components. Split into x and y components using sine and cosine. Now our question is, well, what do we want to use to find something like how high it will reach? Well, which axis is that on? What are we trying to find? Which axis is this on? We're trying to find how high it will reach right here. What is this height? And the answer is, well, that's on the y-axis. So we're trying to find our dy, our height. So we want to use the y-axis. So our step 2 here is analyze the y-axis. You're always going to start with your y values. Let's go ahead and use our y values here to find our height. And the next big thing here that we need to realize, okay, well, knowns and unknowns. Let's say if I want to find how high it will reach, knowns and unknowns, I know my VIY is 10 meters per second. I know my acceleration on the y-axis is gravity. So we do have an acceleration pulling down this entire time, AY. That's going to be negative 9.81 meters per second squared. I know one more thing, and that's this fact. At peak, for an object thrown up, we said at the peak height, our final velocity is 0. Well, that peak height, final velocity is 0, that's on your y-axis. So at peak, our VFY is 0 meters per second. You have that on your known and unknown chart. VFY is 0 meters per second. This is a new implied unknown. A new implied unknown is that at peak, final velocity is 0. Let's go into our unknowns. I said how high will it reach? That is our dy. We could plug that in. Personally here, I would say VF squared equals VI squared plus 2AD. Our VF is 0. Our VI is 10 meters per second, which we're going to square, plus 2 times negative 9.81 meters per second squared times displacement. This is 100. You subtract it to the other side. It equals, I'm going to estimate this to 20, and then it's going to be times our distance. I'm rounding this as 10. Sorry, negative 20. I'm rounding this as 10. Divide by negative 20. Divide by negative 20. And you get your height of 5 meters. And that would be the height that this object reaches. A height of 5 meters. Nobody's in this room. I don't know why I'm wearing this. So we have our height of 5 meters, and we've solved that out. How high will it reach? You can make note of that. Height is also called dy. At peak, the VFY is 0. That's going to be very important here. At peak, VFY is 0. Fantastic. Our next question, how long till it reaches peak height? Well, how long will it take? New unknown, and that unknown now is time. Our new unknown is time. We want to find time to peak height, so which axis we're going to use? The y-axis. You always use the y-axis specifically to find time as well. Always use your y-axis to find time because gravity is on the y-axis, and that's what brings the object to the ground. Let's find time. VIY, AY, VFY, T. Notice these are all y values. Time works on both axes. These are all y values. I'm going to use VFY equals VIY plus AY times T. VF equals VI plus AT for the y-axis. 0 equals 10 meters per second plus negative 9.81 meters per second squared times time. Subtract 10 to the other side. I'm again going to round this to 10. But you divide, you should get a time of 1 second. So how long till it reaches peak height? Well, at peak height, VFY, at peak height, VFY is 0 meters per second. So how long till it got there? 1 second. What is the total time in the air? We talked about this already, again with throwing stuff upwards. If it took 1 second to go up, it takes 1 second to come down. Total time in the air is 2 seconds. And now we have another answer right there, 2 seconds. Excellent. Now we move to the x-axis, and that's step 3. Then you can move to the x-axis. And the x-axis is a bit tricky, because now I'm trying to say, well, how far away will it land? How far away will it land? We called this something in our previous video, we called this range. So I'm looking for the range here, how far away it will land. The range, also called the dx. So new known and unknown chart, and now we're dealing just with the x values. VIX is 17.3 meters per second. What else do we know on the x-axis? Is there any acceleration on the x-axis? Same as horizontal velocity, the answer is no. The AX is always 0. The AX is always, always, always 0. And the last thing we know here, the time. How far away will it land? What time do we want to use? Do we want to use the 1 second to peak or the 2 seconds, which is the total time in the air? Well, when it lands again, it's done. It's done with this journey. That's the total time in the air. Our time we're using for the x-axis is the 2 seconds, the total time. How far will it land? Well, that's going to be called dx, and we don't know it. We'd say, okay, well, d equals vix times t. dx equals vix times t plus 1/2 ax times t squared. Ax is 0. This goes away. dx equals vix times t. And we should get a dx, which is, I believe, 34.6 meters. That is how far away this object will land. That is the range of the object. So our dx is 34.6 meters away. Last question, what is its impact velocity? This is a bit tricky. Here's what you want to realize. The VIY up, that 10 meters per second, is going to be equal and opposite to the VFY down. The VFY would be negative 10 meters per second, because now it's downwards. What about the VIX? Was there acceleration on the x-axis? No. So the VFX is still 17.3 meters per second. Same as it was before, no acceleration, so it doesn't change. It doesn't change because there's no acceleration. Use the Pythagorean theorem here, and what do we get? Well, coincidence, we still get 20 meters per second. The VF at the end, the impact velocity, is actually the same as the initial velocity upwards when it lands at the same height. All of this assume it lands at the same height. Big new known unknowns that we have here. First of all, you need to split things into x and y axes. Use your y values to find time. That's a new known. Use your y values to find time. Other big new known, AX, 0 meters per second squared, although that was in horizontal velocity too. Here's the big one. At peak, VFY is 0 meters per second. At peak, VFY is 0 meters per second. And total time equals time to peak times 2. That's how you analyze a projectile. We're going to talk about these a lot more very soon, but this is a relatively straightforward projectile. Multiple steps. You want to make sure that you're very careful with it. If you're thinking about what's my process, break it into X and Y components, use the Y values first. Time is the only thing that translates to the X-axis, and then you can use the X-axis.